Library API patterns. Now let's switch from the CLI to the Go library. One of the best things about oastools is that all packages follow the same API patterns. Once you learn how to use one package, you can use any of them. We'll cover the functional options pattern, the parse once optimization, error handling, and the 2 API styles available in every package. Every package in oastools gives you 2 ways to configure and run operations. The functional options style uses with functions and a single with options call. This is the recommended style because it's concise, self-documenting, and composable. The struct style creates an instance with new, sets fields directly, and calls a method. Both produce identical results. The functional options style is better for one-off operations, while the struct style is better when you want to reuse the same configuration across multiple calls. The functional options pattern is particularly powerful because options are regular Go values that you can collect in slices. This means you can conditionally add options based on configuration, environment variables, or user input. New options can be added to the library without breaking any existing code. Your current calls continue to work unchanged. This pattern is used throughout the Go standard library and popular packages like Google's gRPC library. Parse once, use everywhere. This is the single most important performance pattern in oastools. Parsing a large spec, reading the file, decoding YAML or JSON, resolving references, building the typed document model is expensive. When you pass a file path to each package, they all independently parse the same file. The parse once pattern eliminates this redundancy. Parse the file once with the parser package, then pass that parse result to every other package using with parsed. For the Microsoft Graph spec at 34 megabytes, this takes validation from over a second to about 30 milliseconds. Structured error handling. oastools uses Go's standard error wrapping conventions. Every error can be checked with errors is, for category and errors as, for extracting structured details. The error hierarchy is well defined. Parse error for parsing failures, reference error for ref resolution problems, validation error for semantic issues, resource limit error when configured limits are exceeded, conversion error for conversion problems, and config error for invalid configuration. This lets you write precise error handling that responds appropriately to each failure mode. OAS errors error types. Here's a reference table for all the error types. In production code, you'll most commonly encounter parse error for malformed specs and reference error for missing references. The resource limit error is important in multi-tenant environments where you're parsing user-supplied specs. It prevents denial of service through deeply nested references or enormous documents. The sentinel errors are constants you can use with errors is for quick category checks without needing to extract the full error struct. Resource limits are a security feature for environments where you process specs from untrusted sources. Without limits, a malicious spec with deeply nested circular references could consume unbounded memory and CPU. The max ref depth limit controls how deep ref resolution can go. Max cache documents limits how many external documents can be loaded. Max file size prevents processing enormous documents. All limits have sensible defaults, but you should tune them based on your environment. Custom HTTP client configuration. When fetching specs from URLs, you can provide a custom HTTP client for advanced scenarios. This is important in enterprise environments, where you might need to go through a proxy, use client certificates, or configure custom timeouts for slow internal networks. The key design decision here is that when you provide your own client, oastools doesn't modify it. The insecure skip verify option is ignored because you should configure TLS settings directly on your client's transport. This prevents surprising behavior where oastools might alter your carefully configured client. Type-safe document cloning. This is a subtle but critical feature. In OAS 3.1, the schema.type field can be either a string or an array of strings. When you use JSON marshal/unmarshal to clone a document, you lose this distinction. JSON.unmarshal has to pick one type. oastools avoids this problem entirely by providing generated deep copy methods that copy every field using its actual runtime type. This also handles OAS version differences. Exclusive minimum is a Boolean in OAS 3.0, but a number in OAS 3.1. Deep copy preserves the correct type for the version you're working with. Line numbers for every element. Source maps are a powerful feature for developer experience. When you enable source map tracking during parsing, OAS Tools records the file, line number, and column of every element in the spec. When you then pass this source map to the validator, fixer, converter, or differ, errors include precise locations. The output format file line column is the standard format that IDEs recognize. You can click on errors and jump directly to the problematic line. This is especially valuable in CI/CD, where you want developers to quickly find and fix issues. Version-agnostic document access. The accessor pattern is important when you're building tools that need to work with any OAS version. Instead of writing version switching code everywhere, you call as accessor and get a unified interface. GetInfo returns the same struct regardless of whether the underlying document is OAS 2.0 or 3.x. GetPaths normalizes the path map. GetSchemas handles the difference between definitions in OAS 2.0 and components/schemas in OAS 3.x. Use the accessor for general-purpose tools and type assertions when you need version-specific fields like OAS 3.x webhooks or servers. Complete library workflow. Here's a realistic example that combines multiple packages in a single workflow. We parse the spec once with source maps enabled, validate it, and check for breaking changes against the previous version. The parsed result is reused across validation and diffing. Errors are properly wrapped with context. This pattern is the foundation for any tool you'd build with OAS tools. Parse once, then apply whatever operations your workflow needs.